Hey guys, and welcome back to Professor Panda. And I am pretty excited because in this video we're going to go over polynomial substitution for integration. And a lot of times this is just called U substitution, but there's actually one version of the U substitution method for polynomials and another one for trigonometric functions in calculus. So to be a little more specific, we're going to call this polynomial substitution. So the general idea of polynomial substitution is we're trying to transform one integral that's of one variable x, in this case it's x, into another integral over another variable u. And this also requires us to change the limits of integration. So here we have a function f of x, and we're going to transform it into another function g of u, which is being integrated with respect to u. So let's go ahead and start off by an example, because I think when we actually do an example of this, this starts to make perfect sense. Okay, so let's say we have the following integral. The integral of, let's do x squared times the square root of x cubed plus 1 dx, and we're going to integrate it. We're going to have our first limit of integration be 1, and we're going from 1 to make it a simple region 1 to 2. There we go. So how can I rewrite this expression, which is a function in terms of x, into another expression in terms, which is another function in terms of u? So here's what we're going to do here. I'm going to try to find a way to where I can simplify this as much as I can, and these take a little bit of practice. But if I notice here, I have an x cubed plus 1, and I know that if I take a derivative of what's in here, x cubed plus 1, I'm going to get something that's got an x squared in it. So I'm going to begin with that. So I'm going to let my u equal x cubed plus 1. When I take the derivative of u, du, I get 3x squared dx, which basically means with respect to x. And now I have a 3 here. And now what I see here, though, is I have an x squared and a dx, which is basically what I have here in this integral. And I just need to find a way to get rid of this 3. So I'm just going to divide both sides by 3, and that's going to give me the following. Du over 3, which is equal to x squared dx. There we go. And so I've made my first substitution here. So I found a way of rewriting x squared dx as du over 3. But before I do rewrite the entire integral, I also need to recompute the limits of integration. So I'm going from 1 to 2. So I know that I'm going to have a u1 and a u2. So I know that my x1 is equal to 1. So when I plug that into u1, which is this function here, I'm going to do u sub 1, where I'm going to let x equal 1, and that's going to give me 1 cubed plus 1, which is equal to 2. Just 1 plus 1 is 2. And now I'm going to do my second limit. So I'm going to have my x2 here, which is equal to 2. Now when I plug that into this function, I'm going to get, so, I like to write so, when I plug that in, I get 2 cubed plus 1, which is equal to 9. So now I have my new limits of integration. Okay, so now I can begin rewriting this and substituting everything. So I have my integral, and I've rewritten x squared dx as du over 3, and the x cubed plus 1 is now my new u, so I can rewrite that as square root of u. And now what I have over here is just the du over 3. With the new limits of integration, we're going from 2 to 9. Because once again, this is going to be my u1, and this is going to be my u2. There we go. And now I'm going to rewrite this, make it a little easier. I'm going to bring the 1/3 out to the front because I think it'll make it much easier to solve once the integration begins. Once again, going from 2 to 9. And the square root of u can just be rewritten as u to the 1/2. Okay, great. And du. Okay, so now we can just begin integrating this like a regular polynomial. Okay, so that's going to give us 1/3. And when we take the integral of u to the 1/2, that gives us u to the 3/2 over 3/2. And just quick reminder, when we're taking the integral of a polynomial, we're taking that power, we're adding 1, and whatever that result is, we're dividing the rest of the polynomial by that. And then we're going, again, from 2 to 9. All right. I can bring out the 3/2 and make this a little even easier. So that's going to be, remember, we're dividing by 3/2, so that's the same as multiplying by 2/3. 2/3 times 1/3. And now I can actually go ahead and begin plugging in these limits of integration into my new polynomial, or into this function right here. So plug in 9, that gives me, let's see, 9 to the 3/2 minus 2 to the 3/2. Okay, great. And I can simplify this a little further. So 2/3 times 1/3, that gives me 2 over 9. Usually, I think sometimes you can just stop it here because you basically have numbers, but we'll go ahead and simplify this even further. 9 to the 3/2 gives me 27. Minus 2 to the 3/2, we'll round it off as 2.828, which is equal to 2/9 times, we'll just say this is approximate to, because we're rounding at this point, 2/9 and times 24.172, so I already used a calculator here, which gives us our approximate solution of 5.3716, okay? And that's going to be our solution to this integral. So everything from this point on is just regular polynomial integration, and the important thing is just remembering these steps. Remember that you're basically looking for something in the original function that you can substitute, so that when you get the derivative and then you get the dx, you can basically rewrite it as du. Okay, so that's polynomial substitution for integration. I hope this video helped. If you guys have any questions, please leave them in the comments. Thank you guys for watching, and I'll see you next time. Take care.